Hey guys, we are on lesson 11, which is called Efficacy of Scientific Notation. So it's about being able to work with scientific notation until you get the intended result is really what that means. It is page 103. So for exercise 1, it says the mass of a proton, and then we have a very, very small number. We could see the decimals over here and lots of zeros. In scientific notation, it is, and we're moving it all the way over to this area right here, right? So it's 1.672622, so that it is greater or equal to 1 but less than 10, right? Definition of scientific notation. So we're going to move it. We have 3, 6, 9, 12, 15, 18, 21, 24, 27. So we're moving it 27 times. Okay, so then we're going to write it as 1.672622 times 10 to the negative 27 power, and then kilograms. Okay. The mass of an electron is that number there, and in scientific notation, it is, removing the decimal there, it is 9.109382291. Just copying it right there. Times 10 to the, and then we count how many places we are moving it, and it is negative 31 kilograms. Okay, and it says write the ratio that compares the mass of a proton to the mass of an electron. So the ratio, mass of a proton to electron, and remember that I write these like a lot. I write these ratios as we've been doing problems a lot, just because it helps you set up a problem so that then you just fill it in with the information that you need. Sorry, my dog is gonna bark for a minute. So it's 1.6726, I'm just copying it from there. 22 times 10 to the negative 27th, and it is over, or you could write it with the colon too, 9.109382291 times 10 to the negative 31. Okay. Exercise 4 is to compute how many times heavier a proton is than an electron. Okay. So it's unfortunate that it is on the other side, but proton and electron. So really you would be just dividing it, right? Because it's saying how much heavier. I might even just do it right here. Do exercise 4 here, just because it's already set up, and then we won't have to keep flipping it. So we're looking for how much heavier proton is than electron, just making sure the ratio is correct, and it is. Okay, so then we would just divide it out here. So let's see what we have. I see, so if we say 27 minus negative, sorry, I'm trying to use my calculator, negative 27 minus negative 31 is, yeah, I'm just subtracting those two just to make sure that it works, and it does. So here, because of the quotient rule, you could, obviously you're going to divide these out, and then you could leave the answer as 10 to the negative 27th minus negative 31, which is 10 to the 4th power. Okay, if I divide 1.67, oh my goodness, that's a big number. I'm just putting in my calculator right here. 1.672622 divided by 9.1093829. It is equal to a fun number. That fun number is 0. I'm just going to put it here just so I could see it. 0.1836159 times 10 to the 4th power. Okay, which I now have to make into scientific notation, or actually just move the decimal, because really I'm telling, let's go back to the question. How many times heavier? So if I just have a whole number, that'd be nice. So let's just move the decimal, 1, 2, 3, 4. So it is about, let's say, 1,836 point, which let's just round since the next number would be 1, times heavier. Okay. All right. Now let's go to exercise 5. Hopefully it is different, or we're done with exercise 4. So on other side, and now there's an example 2. Okay, a different problem having to do with different stuff. Sorry, this is out of focus. Well, it focuses. The U.S. national debt as of March 23rd, 2013, rounded to the nearest dollar is, and we have this, so that would be, we have 100,000 million, billion, trillion, right, at $16.7 trillion and plus. According to the 2012 U.S. Census, there are about, we have 313,914,040 U.S. citizens. Okay, what is each citizen's approximate share of the debt? Okay, so then if we divide this out, this is what you get. So I think this problem is done for you. So you're just kind of looking at the dividing. Right, so you divide there, and each U.S. citizen's share of the national debt is about $53,360. Great. I'm going to pause now since my dog's barking.